Hi, in this lesson I want to go through some of the answers to the questions that were asked about Map B. So we're working on pages 8 and 9 of our Theme 14 booklets. Okay, let's go. The first question then asks for two pieces of evidence that the beds are horizontal. Now the first piece of evidence is fairly, hopefully obvious. There are symbols drawn on the map, which if we look on the key, tell us we've got horizontal beds. That cross symbol is an indicator of horizontal beds. The second piece of evidence, though, we need to look a little bit more carefully at. If we pick one of these beds, say the base of the limestone here, there are three places where we've got the spot height, so the height of that particular bed marked on the map, and it shows they're all 100 meters. So wherever we are on this map and we're 100 meters above sea level, we're at the base of that limestone. The second question then asks for the thickness of the breccia. Now the breccia is the triangular symbol on this map, and the height is, or the thickness should I say, is 20 meters. Now we can work that out either from the cross section. On the side closest to X, we can see that we've got a 20 meter thick bed there. Or we can look at the fact that close to X there, the top of the breccia bed, we've got a spot height of 150 meters. And over closer to Y, at the base of that bed, we have a spot height of 130 meters. So the difference between the two has got to be 20. Question C then asks for the relative age of these beds. And with horizontal beds, like these ones, they're all the right way up. The law of superposition applies. So the youngest bed here, the one at the top of the sequence, is the Greywacke. Okay, we can see that on the cross section right by X there. It's at the top of the sequence. The oldest one, right down at the bottom of the valley, is the shale. Question D asks why you don't have, or why you have Greywacke on the west of this map by X, but we don't see it at all on the east of the map by Y. And the reason for that is that the land on the west is higher. You can see that on the cross section. By Y, the height of the land there gets to just over 140 meters. By X, though, it's about 160 meters. So because Greywacke is the youngest bed, it's the one at the top of the sequence, it's only going to appear on the highest land. Question E. You're asked to describe the texture of the rock shown in photograph B1, and then to suggest the rock unit from which the specimen was taken. Okay. As always, if we're describing a clastic sediment, which this clearly is, we can clearly see the fragments here, we think about the size, the shape, and the sorting. What we're looking at here are small pebbles. You could even measure the size of these using the scale. So these pebbles are maybe 3, possibly 4 centimeters, some of the biggest ones. The shape of these pebbles is rounded, maybe some of them even well rounded, but I think rounded is a good description for it. And clearly as well, it's poorly sorted. There's a big range of grain sizes here. We've got some bigger pebbles, we've got smaller pebbles, we've got granules and probably sand in between them as well. There's a wide range of grain sizes. And because of these rounded pebbles, this rock is the conglomerate. Okay, so there's a mark for each of those things. If we now look at photograph B2, there are springs shown at the bottom of the limestone. Okay, clearly limestone is permeable. We can see, if we look at photograph B2, there are cracks running through this limestone that are going to be pathways for water. We can even see at the base of that cliff a cave, which is just a very big crack. So water will be able to pour through that rock really very quickly. The springs are there because underneath the limestone, we can see we've got a mudstone. Okay, mudstone is generally impermeable. So the water flowing down through the limestone hits that impermeable mudstone, can't go down anymore, so then will start to flow out of the ground, creating that line of springs. Now, those of you that had a go at digging deeper, the hydrogeologist that suggested sinking a borehole for a water well at location B probably needs sacking because it's a terrible decision. You're looking at conglomerate's going to be, or that conglomerate will be impermeable. Poorly sorted sediments like that looks quite well cemented as well. There's no pore space. There's probably no permeability in that. The rock beneath that we can see, shale, will also be impermeable. So you could spend money drilling a hole into impermeable rock and not find any water. If though for a water well he went, or the hydrogeologist went further to the west, somewhere to the west of that spring line, perhaps even into the sandstone or the breccia, and drill down from there, the chances are you'll find a good water well, because there's some porous and permeable rocks there that clearly contain water because it's coming out of the ground at those springs. What we don't know, though, is what's older than the shale. There could be a huge aquifer underneath that shale, but it's a bit of a risk drilling into something where you don't know what the geology is. Okay, so that's our look at horizontal beds. These will come back into some of our maps later on. However, you are not going to get a map at GCSE level that just shows horizontal beds. This is the first step in our understanding of a geological map. So for the next lesson, we need to step up the complexity a little and start to look at beds that are inclined, that are dipping. But that's for another lesson. I'll see you then.